Good afternoon and welcome to our STS-134 Post-Flight Readiness Review News Conference. We are here today to talk about the day-long meeting that arrived at a decision for the official launch date. And here to talk to us about it are NASA's Associate Administrator for Space Operations, Mr. Bill Gerstenmaier.
Good afternoon.
Mike Moses, the Space Shuttle Program Launch Integration Manager.
Good afternoon.
And Mike Leinbach, the Shuttle Launch Director.
Good afternoon.
We'll begin with opening comments, and then we'll be happy to take your questions. Mr. Gerstenmaier?
Thanks, Mike. Again, we set Friday, April 29th at 3:47 p.m. as the launch time for the mission. We had a very extensive review, thorough review today. I think the things that impressed me the most is that the team is still continuing to really work issues and look at the vehicle performance on each and every flight, just like they would during any normal mission. You know, a good example is on the last flight when they were doing the ascent reconstruction data. They looked at the reconstructed ascent performance, and they saw some temperature increases in the data around the 500-second point, and that was due to the fact that the beta angle was a little bit higher and the alpha angle was a little bit higher because of the delay in the launch window. Typically, we launch in the middle of the launch window at the optimum time, but we were at the end of the window, and that caused a little bit of steering to be a little bit different, and that caused additional heating on the wings, more than they expected. So they went back and they actually looked at the certification models, and they found a small error in the certification models that some of those outlying cases were not really accurately modeled in the models. So they went back and redid that for this flight to show that we have plenty of margin. And then for the remaining flight, they're also going to go take a look at that and actually change our certification model. So I think it's a tribute to the team that they're not just taking the data and just looking at it and saying it's okay. They're actually understanding what the data means and continue to understand how they can improve the performance of the vehicles and better understand what we're flying. Also, this vehicle will have more of the brie tile. That's the tougher tile on the bottom of the orbit than any other vehicle we've flown before. We've been putting that around the landing gear doors and the external tank doors to provide a little more debris protection, and we've got those additional tile, the tougher tile installed, and that's good here on Endeavour. We also spent quite a bit of time talking about the systems on board the space station, and they all seem to be functioning well. We're still continuing to learn a lot about the environmental control system on space station, the oxygen generation system, the water processors. Some of the equipment we've been flying up on the shuttle will be critical to keep those systems up and operating and moving forward, as well as some of the samples have really been helpful coming back from station, that we can actually understand what's going on with station. We also talked a little bit about the Alpha Magnetic Spectrometer. Professor Ting gave us a little discussion on what he hopes to see from his instrument on board space station, and that was a pretty exciting discussion that he gave us. The fact that we get a chance to look back at the Big Bang and see if there's antimatter that occurred then is a pretty promising piece. Also to look at high-energy particle physics kind of parameters, similar to what we'd see in a ground super collider, will be also another outcome of the AMS. And then the third thing it'll allow us to do is to just learn more about dark matter, which makes up a large portion of the universe, which we really don't understand why it's there, or matter that we can't see with the classical instruments. So it was very interesting hearing about AMS. Then the last thing we spent quite a bit of time talking about was the external tank. This is ET-122. If you remember, it was at MAF during Katrina. When Katrina hit, a portion of the roof came down and struck the tank, and we reviewed in excruciating detail that this tank is really ready to fly, that there's no concerns. We reviewed all the analysis they did to show that this tank was certified to go fly. We also talked about this tank from a stringer standpoint, and are the stringers of the right material to go fly. I think we have 3 strong indications that these are the right stringers, the right material, and they're not the defective material, so that was encouraging to us. And then the last thing we went over was that this tank doesn't have some of the modifications to it that other tanks, external tanks, have had, so we expect to see some foam loss. If you remember, we used to lose foam around the LH2 iced frost ramps on the hydrogen tank because there was a little guide pin or alignment pin that would allow some cryo pumping and ingestion around the ice frost ramps, which would cause some foam to come off from those areas. We fully expect this to occur on this tank. We didn't make the modifications to do that. It'll again be late losses of foam, but we expect to see some foam losses in that area. The ET team also looked pretty extensively at the foam loss we saw on the just below the intertank region on the LH2 side. And we understand, or we think we understand, again, why that occurred, and we'll see. And we've really done the right things to make sure that it's okay. The performance was also acceptable in the fact that it came off late, just as we predicted. But the teams went back and they just didn't accept the fact that it came off late. They actually went back and redid models, updated risk assessments to make sure that we're still okay to fly. So it wasn't just saying we lost foam and it didn't cause us any problem. It was okay. They took it a step further, said how big could the foam loss be? Could it be at a slightly different time? Would any of that cause us any concern? So they spent quite a bit of time reviewing that to make sure we were comfortable with what we had seen from the last flight. So again, I'd say we reviewed everything. We spent quite a bit of time talking about all the things, and I think the team was unanimous and we're ready to go fly as I described earlier. So it was a very good review. So, Mike?
Thanks, Bill. So again, yeah, it was a really good review today from both station and shuttle's perspective. Just to continue on the external tank discussion, ET-122 has been kind of called the hurricane tank since it went through Hurricane Katrina. It had the return to flight mods made to it, like Bill said, to make its debris, to help reduce any debris liberation off of it, with the exception of a few areas we decided based on risk that we did not need to address. And then we went and did the ET stringer mod to it, even though we subsequently got enough data to prove that the stringer material on this tank is not of the same family as what we had on the last tank and we'll have on the next one on STS-135's tank. And so it didn't really need that stringer modification. But when the time came in the schedule to be able to do that work and have enough time to still make the launch date, we needed to move out on doing it without all the data. And then we found out afterwards that we didn't really need to do it. So the team did a really good job of just double-checking that we have plenty of test and analysis to show that this modification made to good stringers doesn't change our dynamics or our performance on the tank at all. But really, what kind of wraps it up is it's hard to see because it's around the corner, but you might see it in some of the shots. There's a door on the side of the inner tank. We call it the inner tank access door, and it has a logo painted on it. For the first time ever in the history of the shuttle program, we actually painted a logo. It's a hurricane with the shuttle stack lifting off through the eye of the storm. Really try to kind of represents what this tank has been through. But to me, more importantly, what it represents is what the external tank team has been through. If you think of it, we had the tank at MAF in Michoud near New Orleans. When the Columbia accident occurred, they looked at that tank to see what we could do to get it back in line and start flying it again. Then Katrina hit, damaged the tank. We had to stop work on it and in fact, stop work across most of the plant and recover. So that logo kind of really represents to us emotionally what the tank has been through, but more importantly, what the team has been through. If you think about it, Katrina did nothing to our tank compared to what it did to the people's lives down there. And even to this day, they're still recovering from that. So an absolutely amazing job by our external tank team. The motto of that group has been to finish strong, and they are most certainly doing that, not only with the stringer issue we had on the last flight, but just this tank to get it back into the flight assets, given where it went with its pedigree, is a really testament to the dedication and the resiliency of that team. Focus a little bit on the mission that we're going to do. We talked a lot about our timeline. This is going to be a very complex choreography, a lot of small tasks that all have to go when they're supposed to, or they have to ripple down and find new homes, which makes it a big challenge for the mission operations team. And they have a pretty good plan with a lot of backups in it to be able to handle that. On flight day 3, after we dock to the station, we will take the ELC pallet out, which has a bunch of external ORUs that are spares for the station. And so they'll go stow that on the station. On flight day 4, we'll lift out AMS and go put it on the other side of the station. So by flight day 4, we'll have both of the big main payloads out of the bay. And then on flight day 10, we're actually going to leave behind our boom, our inspection boom, the OBSS. This is the extension arm that we use to do shuttle TPS tile and wing leading edge protection inspections. We do it on flight day 2 after we get in orbit. We make sure we didn't have any ascent damage. And then we do it a couple days before we land to make sure we didn't have any micrometeorite or orbital debris impacts to the RCC on the wing leading edges or the nose cap. We're going to leave that boom behind on station. We've left it behind once before. If you remember way back STS 123 and 124, that boom came about after Some of those modules were built. The Japanese, the GEM module, was a little too big to have the OBSS in the payload bay, so the mission before it left its boom behind. And after they installed the GEM on the following mission, they grabbed that boom and used it for their inspections and brought it back home. We're going to use that same hardware to stow the OBSS, but this time it's going to stay on station. And you go way back to STS 117, 119, I can't remember my numbers. But when we were moving the P6 solar array, we had that tear in the solar array, and we used our boom on the station arm as an extension to let Scott Parazynski go out, extend the reach, and do a repair. That's basically why Station wants that boom. It gives them some extra reach and can get to some pieces of station that they can't get to right now just with their station arm. So that boom will stay up on station. It'll be modified a little bit so that it can be grappled by the SSRMS, the station arm, down at the end. Right now it can only grapple it in the middle of the boom, so we'll move that fixture down to the end. The sensor pack that we use, the laser sensors and the cameras, are going to stay on, but they're not going to be powered, so they're going to die pretty quickly. There's no plans for the station team to use those sensors, but the boom will have the mods to be able to go add sensors at a later date if it becomes necessary, and they find an operational reason to do that. But for now, it's just going to basically be an extension stick that we're going to leave behind on station. So because of that, we're going to do just like we've done on STS-123, and then we did again on STS-131 when our KU band antenna failed. We're going to do our late inspection, that final inspection of the orbiter TPS while we're docked to the space station before we leave the boom behind. So we'll do that very well understood plan. Like I said, we've done it twice before. The crew's been very well trained. That should go off without a hitch. That's going to happen on Flight Day 11. Flight Day 12 will be EVA 4, the final EVA, and that requiring EVA to go install the boom on station. So you'll see that sequence of we do a late inspection and then we stow the boom on the EVA the following day. We talked a little bit about our mission duration. We're going to lift off with a 14-day planned mission. We have 2 extension days in addition to the 2 weather and systems wave-off days that we keep for deorbit landing contingencies. But so we have 2 mission extension days this time. We do plan on using those. We didn't want to commit them pre-flight just in case something happened that made us want to readdress why we had committed them. So after we get docked to station, probably around Flight Day 5 or so, the mission management team, both on the station and the shuttle side, will take a look at where we're at. The mission ops team has a really good plan where those 2 extra days will go in, and we'll probably add those 2 days, taking it to a 16-day mission. But we won't do that until we get in orbit and see what we got. The main activities are really station outfitting that need to be done. The station, we already know, have a whole host of tasks we need to fill in on those 2 days. So those will be very helpful. And if we lift off on time, we'll have plenty of cryo to be able to do that. Like I mentioned, EVAs, we have 4 of them on this mission. You're going to see us use a new pre-breathe protocol. Pre-breathe is what we have the crew do. It's a lot like when you're scuba diving. The guys who go out in their suits go down at a lower pressure. We have the suits at a lower pressure rather than atmospheric, 14.7 psi. So we need to purge the nitrogen out of their blood before they go to that lower pressure. The protocol we mainly use these days is called camp out. The night before the 2 EVA astronauts go into the airlock, they shut the door, they lower the pressure just in that airlock rather than in the entire station, and then they kind of camp out all night long at that lower pressure, get up in the morning, get on masks, do their activities, get in their suits. This new activity basically is called in-suit light exercise protocol, and exercise is a real stretch. So the morning of, the crew doesn't have to camp out, so the morning of they'll go in, they'll get into their suits, they'll start breathing pure O2 for about 50 minutes, 50 minutes more than they normally would. And then during that time, they'll do what we call light exercises, which is really just very slow flexing of their elbows and legs. And so they're going to basically bend their knees a little bit, bend their hips, bend their arms. Like I said, calling it exercise is a stretch. They're not really going to do much at all, but just to get your metabolic rate up a little bit. And then after that 50 minutes, they'll have 50 minutes of rest, again, still on pure O2. So 100 minutes of pre-breathe will make the equivalent of having camped out overnight at a lower pressure. You'll still get all the nitrogen out of your system, and operationally it's a much more friendly operational system of pre-breathe protocol than either of the other methods we use, mostly because the crew doesn't have to be camped out by themselves overnight, and you avoid some of the problems, like, for example, a false smoke alarm on station would cause that airlock to be repressed, which would break the protocol and prevent you from going EVA the next day. This will avoid any of those problems. So both the operations team in Houston and the crew are looking forward to this protocol. We're going to use that on EVA 3 as kind of a test run, and if it goes well, we'll probably use it also on EVA 4. It's been through extensive ground testing and approval through both NASA chain and independent medical chains, so it's a very well-approved procedure. We just want to kind of make sure we got the big EVAs behind us, and then we'll try it on the last couple just in case we run into any hiccups. Other than that, the other thing you'll see us do a little different this time, we're flying a sensor in the payload bay called Storm, which is effectively a relative motion sensor that was going to be flown on Orion that we'd use for automated docking. With the shuttle, there's a sensor out there we call TCS, a trajectory control sensor. It's basically a range-finding laser. The Storm payload has a similar thing, but it's a much more active system. So after we undock, we'll do our normal undock, we'll fly around with the space shuttle, and we'll do our separation. And then after that SEP burn, we'll do a couple more burns to put us on our re-rendezvous profile. Grand total about 4 hours. We'll come back around again and close back in on station using this other sensor, the Storm sensor, rather than our TCS sensors. We'll go out about 30,000 feet total before we come back in again, and we'll come back up what we call the R-bar. So if you think about it, the station will come in directly below the station. That's the same point we do the RPM, the rendezvous pitch maneuver with the shuttle when we come up. The shuttle then kind of transitions up and flies in on what we call the V-bar. We're going to come up on that R-bar about 1,000 feet away, and then we'll stop and separate away from there. We don't need to go any closer to test out the Storm sensor on this flight. So it'll be a really good hands-on use of some new technology and to demonstrate its capabilities in docking and rendezvous in the future. So that's a little different thing we'll do after we undock. We kind of come back again, take another look at station, and then head home. All in all, like I said, it's going to be a very busy mission, very packed, and a very exciting one to watch. I'm looking forward to it. But Endeavour and the team are in great shape. I'll let Mike tell you more about how the launch team's ready to go come 10 days from now.
Okay, thanks, Mike. Well, the final processing flow for Endeavour is going extremely well out the pad, especially given the extra days we were given by the program, an extra 10 days. Last night we completed the ordnance installation for the different elements, which separates the orbiter from the MLP and the different flight elements themselves. That's all complete and good. We'll get into the pressurization of the high pressure gas bottles tomorrow night. And the rest of the pad flow is really pretty easy. We have all Easter weekend off, which is nice for us. We'll come back in next Monday, close the payload bay doors, and a week from right now we'll be into launch countdown for STS-134. One thing to mention: at the end of March, we did have some adverse weather at the launch pad. That was reviewed in detail throughout the last couple of weeks or so, and in addition today, each element reported out. We had small hail. We experienced small hail in the external tank. We also had some high winds. Those were all dispositioned perfectly fine to go, so no issue from the adverse weather if you hear about that. A good, easy launch countdown, a standard countdown for us. We do have a little bit of an O2 offload after PRSD load, but we hope to get to the opening of the launch window Friday the 29th at 15:42 Eastern Time. Endeavour and her team are doing really well for a final flow. Very proud of the team, and we'll have a good launch and a good mission. Thanks.
All right, we'll begin with questions here at the Kennedy Space Center in Florida. Please wait for the microphone, state your name and affiliation, and please address to whom you're asking your question, and we'll begin with Marcia.
Marcia Dunn, Associated Press. Could one of you just run through the window, what's available if you don't get off on the 29th, and then just sort of refresh us on how June 28th is looking for Atlantis and how that's stacking up?
So let's see, for the launch window, we start on the 29th. There's an Atlas launch coming up on the range on the 6th of May right now, so we would be able to try, if we needed to, all the way through and including the 4th of May before we'd have to stand down for that Atlas launch. As Mike mentioned, with the pad hold we have and the PRSD offload, we'd have to top off, and it would take us more than our normal 48 hours, so the timing lines up pretty good that if we were stretched out that long for some reason, we could reload our cryo and be ready to go on the other side of that window. It would, depending on whether they go on their first or second attempt, we could come back around the 9th or 10th. There's some station Soyuz undocking issues that we may or may not have to address if we come back, but somewhere around the 9th or so, we'd be coming back for another launch attempt. We'd have to wait and see why we were having the problems in the first place before we can make that for sure. And then we can go pretty much through the end of May with that launch window. There's some implications to doing so on the station mission we'd really need to make sure we talk about, but it's legal launch window for us if we needed it.
And Atlantis processing is going really well. We're still shooting for a May the 12th rollout of the OPF and out to the launch pad on the 20th. And we have TCDT on June the 2nd. We have a tanking test planned for the 7th of June. And right now all looks good for the end of June, June 28th for the final flight.
James.
James Dean from Florida today. Mr. Gerstenmaier, could you give us a status of where you are with the budget after the recent budget deal for the shuttle program? You know, for example, how far could you push out 135 given the funding that you have available? Is that why you're now sticking with your June 28 instead of pushing it out later into the year?
I guess it's really not budget driven. We just take a look at what we need to go do, and if the teams are ready to go fly and the hardware's ready and everybody's trained, I think June 28th is what we've been planning for, and that's kind of where we're aiming. If we need to move a little bit technically, we'll move a little bit. We're not, overly constrained budget-wise, but there's no big advantage of moving the flight multiple months to us from a hardware availability standpoint. We reviewed in detail with the station program what additional hardware they could fly, what things would help them out, and there was no big driver one way or the other. So we think the end of June is about the right time to go fly, and we'll just continue to follow the processing and the crew training, and if something comes up that makes us move, we'll move where we need to move. So we have sufficient budget to do what we need to do.
If something comes up, some kind of new technical issue or something, is there essentially a deadline, a last date by which you would, you have to get flown, or you couldn't pull it off anymore?
I don't think there's there's not a hard constraint. We'll work it and depend, where we are and see what we need to go do. But we'll let the technical data drive us where we need to, and then I'll work the budget stuff once we understand the technical problems that push us where we got to go push it if it needs to move. So there's not a financial constraint that says at X date we can't fly beyond that date.
Bill.
Bill Horowitz, CBS. Two quick ones from me. Could one of you guys give me whatever the risk assessment was for this flight? I just was curious if the use of this tank changed the numbers even a little bit. I was really looking for the total number and then debris and ascent, if you had those in your charts.
Let's see, the MMOD, micrometeorite on-orbit debris, or orbital debris risk number was 1 in 277, 279? 275. Anywhere between 275 and 279. I'll look it up here in just a sec. That's a little lower than it would be because we're doing this inspection. Normally we do it about 3 or 4 days before landing. We're doing it even earlier than that. So there's a couple more days that we're exposed to micrometeorite debris that we then don't go look to make sure we didn't get hit. So that makes that risk number go a little bigger. The other piece is when we're docked to station, the inspection coverage we get is not 100% coverage. There's a few areas that aren't that are deemed low risk on the RCC that we can't see, so that makes that risk number go up because there's a few areas that you couldn't see. So from that standpoint, the number's a little lower, but it was a known risk trade with the gain of leaving the boom behind for station future ops. And we got 1 in 275 is the number.
And then the debris and ascent numbers?
Yeah, they don't present that one to us. We don't compute that one per flight anymore.
Okay. Yep, and we don't see it. I mean, we looked at it kind of from an overall risk standpoint, and we really don't see a significant difference between this tank and our other tanks. Before, but we will see potentially some more foam loss, especially after the aerodynamically sensitive time frame, because we know we have this potential cryopumping associated with our hydrogen ice frost ramp. So we know we will see some foam loss, but again, it'll be late enough that it doesn't impact any of our risk numbers from an overall standpoint.
Overall risk of 1 in 75 or whatever that number is, that's pretty much the same as always.
Yes.
Yeah, we did review that from an external tank risk is unchanged.
Thanks. And one for Gerst. Where do you guys stand on shoehorning a fly around into 135? I know y'all are looking at that. I know the Russians are, and I know that's a tight schedule with the 4-man crew. So where does that stand?
Well, we're still taking a look at that. We're putting the details of that overall timeline together. The program's made some decisions about what hardware gets transferred back and forth, and that kind of frees some things up. And we'll see how all that fits and see if a fly around works for 135. So we're off evaluating that and see if it makes sense. And it's kind of part of the overall, kind of as we get to the final mission build or the final timeline tweaks, we're going to go see if that fits and makes sense for us to go do.
Are the Russians at least amenable going in?
Yeah, I think the Russians are supporting. We're supporting this time, but again with the potential launch of the Soyuz coming up, we wanted to delay the landing to be consistent with keeping the amount of time. We only have 3-person crew on board station to about the same time frame as before. What the Russians would have done for this flight is they would have undocked the Soyuz as part of their return configuration, done the fly-around data, and then returned the Soyuz potentially to the ground. Then with the Soyuz launch delay to June 7th, that would allow a longer period on orbit with us at 3 crew. We didn't think that was the right thing to do from a station utilization standpoint. We want to keep our crew at 6 as long as we can. So we asked the Russians to delay that landing, which they've agreed to do, to keep the same amount of time where we're down at 3-person crew. So that's why we moved the fly around off of STS-134. And then at the same time, we asked the Russians to take a look at it for 135. But we need to look at it from an overall timeline standpoint to make sure we don't put too much pressure on the crew with only the 4-person crew there on 135. So I'd say that's normal work in front of us. We'll evaluate that in the next couple of weeks.
We have some reporters in Houston, so we'll take one more question here, then go to Houston, and then come back. Go ahead, please.
Jackie Goddard for the Times of London, and it's a question for Mike Lineback, if I may. The workforce here seems to have such a close and respectful bond with the shuttle. It seems a very emotional attachment there. Can you tell us how people are coping with the prospect of the end of the program and what the mood and atmosphere is here?
Well, the mood I'd say has been consistent over the last several months, in that we know the end is coming and we're dealing with it. We did have a layoff last Friday, a week ago, 535 people. So that put a little bit of a somber mood on the team, I'd say. But we're dealing with it. We have sufficient workforce to get all the work done and launch this thing and land it and the next one as well. The emotional aspect is very, very real, and it's very difficult to put into words. But I think all of Kennedy Space Center got a big boost when we got the word that we were going to be able to keep Atlantis here, and so we're looking forward to that, the ultimate display of the ultimate spaceship here at the Kennedy Space Center Visitor Center.
Okay, let's go to Houston and see if we have any questions there, please.
Gina Sinceri, ABC News. Let me give this to Mr. Gerstenmaier. I'm stuck asking the question, did you ever consider moving the launch off April 29th, since it conflicts with an event that's not happening in this country, but's happening overseas?
The frank answer is no. I didn't realize when the wedding was until we moved the launch date, and we moved the launch date essentially because we needed to deconflict with the progress. And we wanted to pick a date that gave us a reasonable number of attempts before we ran into any other range conflicts, and that's how we set on the 29th. So we kind of set that date independently, and then as I was setting the date, somebody called me and told me about the wedding, and that was a consideration. But we work beta constraints and we work launch range constraints. I haven't yet put on our manifest charts wedding constraints, so we didn't factor that into our thinking.
Mark Carreau from the Houston Chronicle. I have a station-related question. If I recall correctly, you had a remote power controller issue on the starboard truss, I think, at the end of last week or the beginning of this week. And I just wondered if that has any ramification at all for plugging in the AMS?
No, it doesn't. It powers some of the rotary thermal joint activities and an MDM, an S1 MDM. And I think I just got a page prior to coming here that they actually reset that, and it reset with no overcurrent. So I think we're in good configuration. We discussed that pretty extensively at the review, and it wasn't going to be impact to any of our future operations. And then I think last night we lost a camera RPC, and it looked like that was an actual short. We saw a high current event. So we'll just leave it's for a camera heater, and what we'll do is we'll just leave the camera powered, and it'll provide enough heat to keep the component warm. So I think the RPCM, the remote power control module that you talked about, Mark, it will not be an impact to us, and it looks like at least it was resolved today. And it wouldn't have been even if it wasn't resolved. We had plenty of time to go work the issue.
Okay, we're back here at Kennedy Space Center with questions.
This is Greg Pallone, News 13. This is either for Bill or either Mike. Can you think of any fitting tribute for Endeavour as it being the youngest orbiter? Is there anything that comes to mind when you think of Endeavour and the fact that it essentially replaced Challenger? Are there any thoughts in your head where you would you would think of some words to describe Endeavour and its service and these significant missions that have been accomplished on it.
Let's see. For me, kind of it's the engineering answer, but we're still focused on the mission. So to me, the best tribute to Endeavour right now is to go get it launched next week and get it into orbit and let it go finish out and finish strong here with the mission to station. And then when it comes back, then I'll start thinking about what that ship meant and what it's done. It's a pretty big career. They gave us a packet on the way over here, and I didn't even have a chance to read some of the history and the firsts that it's done since it's been delivered here. And being the youngest ship, so maybe Mike has some thoughts about having worked with it a little more hands-on. But again, I don't mean to take the cheesy answer out, but we're kind of holding on, reflecting until we're done, and so we won't be done for a couple more weeks yet with Endeavour.
Well, see, I've been working with Endeavour since she arrived here. I was the NASA test director for her first flow when we did a flight readiness firing out the launch pad and tested out the MPS system and the main engines, and then the launch, of course. So I've been with Endeavour for her whole flow. And last week, Dana Hutcherson, the flow director for 105, and I went out to the pad and went looking around and just reflecting a little bit. There are a lot of views of Endeavour still look almost brand new. I mean, the top of the wings, the blankets on the wings still look like they just came out of the factory. And so for me, it's like retiring a friend early. But it's a good friend, and so we're going to get a good mission off, just like Mike said, and we're going to do the engineering, all the engineering work on this last flight like we did on the first flight. No changes there. And again, we'll be able to reflect after she lands and brings her crew home safely that that was her final mission.
And when I look at this mission, I think a little bit about the AMS, and this is a pretty unique payload that's going to space station. We don't typically fly a payload that takes as much of the cargo bay as AMS does, and the potential science that it can return to understand dark matter that lives in the universe, and to understand these unique high energy particles that are out there in space is going to be tremendously important. So when I see Endeavour flying this really unique instrument to space station, this is a pretty unique mission to kind of close out Endeavour's career. It's not your run-of-the-mill kind of missions. This is really a unique chance to see this vehicle carry a very unique science instrument to space that has the potential of returning really earth-shattering science to us.
Aside from all the wonderful stuff that's happening with the shuttle on this mission, there is that added public interest, of course, in Mark Kelly being commander and the story of that he's been through over the last few months. Can you talk a little bit about what a roller coaster that's been for the crew, really, and how they've come through that and worked together to get to this point ready to launch?
Yeah, I can't talk in any specifics, but I will tell you that again, the crew has just done a tremendous job of staying on focus and being trained and ready to go fly. We were originally scheduled to fly on this day, April 19th, and the crew was ready to go meet that date. They were fully trained. They completed all their training activities. And then when we slipped to launch 10 days, they got to go ahead and hone some skills and move some more things. But again, I will tell you, it's a testimony to the entire crew to stay focused, to compartmentalize, and to do what they need to do for this mission. When you see the EVAs and the spacewalks, these are not trivial spacewalks at all, especially the one with the ammonia servicing and ammonia refilling is a big task. And Mark will play a key role in kind of watching over that task to watch the spacewalkers as they go do those EVA tasks, and kind of be the conductor in a sense of watching some of those activities occur from an overall commander standpoint. And so he'll play a key role in all that. And he's also plays a key role, obviously, in the ascent and entry, and he's done a good job of being trained with all that. So I think the good thing is that they've been able to work together as a team, and they're about ready to go fly, and that's good.
Marcia?
Marcia Dunn, Associated Press, possibly for either the two mics. Are there any special accommodations being taken now, or any plan in case Congresswoman Giffords can attend the launch as her husband hopes? And do you expect that to be a distraction for your teams on launch day?
Well, see, from the launch team perspective, it won't be a distraction. There's a whole separate team working that issue. I'm not quite sure if she's coming or not, to be honest with you. I've turned that over to other people, let them take care of that, so I can focus on the countdown and the launch team. I hope she comes, but I don't know if she will or not.
Bill?
Yeah, this is a dumb question, but I've been asked this a million times since the announcement last week about where the orbiters are going, so I'm hoping one of you guys will explain it, and then I don't have to answer it anymore. Why not just send Endeavour to California instead of bringing it back here? Why do you have to bring it back here?
You mean for plan the landing
yeah.
in California?
Yeah.
So when it lands, it'll be full of all kinds of hazardous stuff. Pyros that haven't been fired yet, hypergalls in the OMS and RCS system, hypergalls in the APUs, hydraulic fluid all over the place. You know, it's not something that you'd hand over to the public in that configuration. So we need to bring it home here to safe it. We don't have the facilities to do that out in California.
James?
James Dean with Florida Today. Two follow-up questions. Any consideration of Atlantis landing in California on its flight on purpose to give it a farewell tour of a ferry flight? Personally,
Again, I will tell you what I've asked the team to do is I want us to make these last flights as much as normal flights as we can. So we didn't plan to do anything special. We'll let the weather tell us where we're going to go land. We'll do the normal mission planning the way we are. I didn't want to interfere with the team planning. You know, we've spent a long time, many years, 30 years, you know, honing the way we do flight rules, honing the way we build procedures, the way we do plans. And I wanted all these flights to be done as much just like the ones we've done before as the ones that are at the end. So we made no special accommodations for that. In fact, I was asked, should we do that? I told them I did not want to do what you suggested. I wanted to make it just a nominal end of mission, let us do the +2 weather day planning stuff just like we normally do and treat it just like a normal flight, and we'll see what the conditions and the flight rules drive us to as we move forward.
Yeah, just one more from me that I meant to ask earlier to Gerst. The business of the leading edges and the temperature constraints that you went back and reevaluated, which way was the error made? Was it you had less margin than you thought, or you had more than you thought? And I was just curious how that played out.
The model under-predicted what we would see at launching it late in the window. So in other words, it was warmer in the actual case we flew than the models would have predicted.
But it wasn't anywhere near what the actual constraint really is.
No, it was. It didn't. It was. Yes, there was plenty of capability in the vehicle beyond what it design standpoint. But what it showed us was our certification analysis, if we would have counted on that, wasn't exactly done and wasn't done correctly. And then what's important for that is it's not just this case. Then you want to look at transatlantic aborts. You want to look at all the other scenarios to make sure that there's not something from a certification standpoint that we missed now that we found this model error. So it was a real tribute to the team that they saw this and it surprised them. And then they just didn't just pass it off. They actually kept looking to see what that would mean to make sure that we are really certified for all conditions that we expect to fly.
Okay, we'll wrap it up with a question from James Dean.
Yeah, I'm sorry. I was just wondering if you could discuss a little further these extension days, a couple on the last flight and a couple more probable here. It seems like to kind of underscore Shuttle's ending and got to just cram everything we can into these final missions. Are you doing it essentially because you can, or do these things really actually need to get done in a way that's different from, you know, what happened 10 missions ago, what you had to plan?
And I can, Mike can add a little bit too. What's really happening with Space Station is, you know, we have 17 vehicles that go into station during this period. So this is a very busy time on Space Station. So that takes a lot of time for the crew away to handle the ATV docking and departure, the HTV docking and departure, the progresses that are coming and going, the Soyuz, et cetera. So the crew doesn't have as much time on orbit, and we're also trying to focus on research and do a lot of research. So what these shuttle flights are allowing us to do, for example, our oxygen generation system, we have a new a system we'd like to put in there that will control the acidity or the pH of the loop into the oxygen generation system. The current filter we have causes too high a delta pressure. We can't run the pump, so we have a low pressure system we would like to install. That's about a 4 or 5 hour task to go do that and install that. We would like to do that during one of these extension days so we can get the shuttle team along with the station team to go put that in, and we can get the oxygen generation system then fully up and ready to go support. If it doesn't occur during this mission and we can't do it, then we can push it off to the increment. The station crew can do it later, but then it'll take some time away from research. So what we're trying to do is we're identifying tasks that that really helps station end up in a much better configuration. So we're taking advantage of that extra workforce that comes up with the shuttle to really take advantage of these items. And that's why those 2 days are pretty doggone important. And if you look at the actual tasks we're putting in, they're not trivial tasks. They're high priority tasks that we're going to have to do probably in the next month or two. And this allows us to get ahead with those tasks.
Okay. I think that wraps it up. We really appreciate you coming today. Just wanted to remind you that STS-134 activities begin in earnest again here on NASA television 1 week from today, April 26th at 10 a.m. Eastern Time with a pre-countdown status briefing. The STS-134 flight crew arrives here at Kennedy Space Center at 12:15 that day, and at 2 o'clock in the afternoon, the countdown officially picks up, all leading toward launch on April 29th at 3:47 p.m. Eastern Time. And you can keep up with all the activities on our website at www.nasa.gov/shuttle. Thank you very much.